What is going on, everyone? This video is a walkthrough on how to query CloudWatch logs using Python and write the query data to an S3 bucket. Now, this walkthrough goes beyond exporting the logs and includes data transformations to make the semi-structured data more query-friendly in S3. So before we jump into some Python code, this video will walk through querying a log group in CloudWatch logs using a Jupyter notebook on AWS, using the AWS Data Wrangler library in Python to query the log, transform the data using the pandas library, and then exporting the data to a JSON file to S3 using the AWS Data Wrangler library again. When writing the data, I will also cover how to write to a glue catalog table in AWS so the data is accessible through AWS Athena to empower users in your organization to perform ad hoc analytics on the dataset. Although I'm demonstrating this through a Jupyter notebook, you can easily swap out the Jupyter notebook for a Lambda function to make this process fully serverless. Alright, so we're in our Jupyter notebook here deployed on AWS from the SageMaker service. And to get us started here, I've just installed the AWS Wrangler library that we're going to need by doing pip install. The next step is we're going to have to import the libraries that we're going to need to ingest, transform, and write our data to S3. So I've imported the DataEng library to do some datetime calculations to query our logs from CloudWatch. I've imported logging to track some messages associated with our Python code, and imported AWS Data Wrangler library, which is going to be the key library here that's going to be reading and writing data, and then using JSON and pandas library to help us with some transformations. Great, so once we import our libraries, the next step here is to get our CloudWatch logs from the CloudWatch service for the CloudWatch stream we're interested in ingesting. But before we move on to that, let's take a look at what the payload from the log stream looks like. All right, so I'm in my CloudWatch log stream that I want to ingest in S3. And as you can see here, I'm getting a JSON payload within the message variable in my CloudWatch log group. So this is the data we want to ingest into S3. So we see here that there is an order ID, the amount, the approval date, who approved it, and the timestamp that this purchase was approved. So there's three things that are important to us to pass into AWS Data Wrangler to read this information in. We're going to need to pass the log group name, the stream name, and any time filtering that we want to apply on our query. So I went ahead to paste in the code already that we're going to be working with. Let me just walk you through what I've done here. So in order to set a time window for the CloudWatch log that we're going to be querying, I've got the date time in UTC that we're going to be passing in, and this is going to be the current time, and then this is going to be the start time of the query. So I want to only ingest 24 hours. So here we can see that we're minusing the current time by the last 24 hours to give us 24 hours ago. Perfect. So now that we have our time window set up, let's look at our function that's going to be retrieving our logs. So all I'm doing here is wrapping the read log method from AWS Data Wrangler in this getAuthLog function. So this function is going to retrieve our logs as a pandas data frames. So our first line of our function is our query to query our CloudWatch logs. And as you can see here, we're passing in the log stream name as a variable, and we're going to be retrieving the two fields. So the timestamp and message field. We're going to be sorting it by timestamp descending. And the next line here is going to be returning our pandas data frame from the logs that you just saw in CloudWatch logs. So the first parameter is going to be our query that we're passing in. The second parameter is going to be our log group that we're interested in tracking. And this takes in a list, and I'm just passing in one, but if you wanted to track multiple logs, you would pass in multiple names here. And then my last two variables are the start and end time of our query. And then the return of this is going to be a pandas data frame. Great. So in my next line of code, all I'm doing is now calling this function that I just wrote. We're passing in the log group that we're going to be querying and the log stream over here called purchase approval and the start and end time. All right, so let's just give that a run. And using that head method here, I've just returned the top 20 messages in our query. Great. Now we have a pandas data frame of our log. So this is the first step. So we can see that timestamp and our message that came through. Now this is a great first step. So you can see we have the JSON payload, but it's still within this message variable in our pandas data frame. And before we write it out, I want this to be more usable. I want to store this specific message in our pandas data frame. So the next step here is we're going to be transforming this message. All right, now let's look at the method to convert our CloudWatch log into a data frame that's more usable. All right, so I'm just going to paste in my function that I pre-written to save us some time. And just to walk you through here what this function is doing. So the input is going to be a pandas data frame. So we're going to be passing in this pandas data frame that we've created above, and it's going to be returning a nice clean pandas data frame that's ready to write to S3. So the first step here is to create an empty Python dictionary, which just has our keys. So these are the keys that we're going to be writing to S3. We have our order ID, amount, approval date, approver name, and timestamp. So now all we're going to be doing is filling this dictionary with the values from CloudWatch logs. So now we're going to be reading the message column in our pandas data frame that was being inputted from the CloudWatch service, doing a quick QA check to make sure that we have all the keys that are coming through as expected. And if they don't exist, we're going to be skipping this particular row. Now the next step here is to convert our string, which is coming from pandas, that JSON that I showed you, into an actual Python dictionary. So we're using json.loads to do that. Now that it's a dictionary, we can simply load those values into our dictionary that we've created above. Great, and the second last step of this function is going to be converting our now created dictionary outside of the loop into a pandas data frame again. So we're using the pandas.dataframe method to do this. So this is going to be the Python dictionary. And now here we have a transformed pandas dictionary from the message that we saw here. So now we're going to have a nice pandas data frame of all our message values that we see here. All right, so now the next step is I'm casting my data types that I want to write to S3 just to make sure we have consistency here. So I've set my integer fields, my strings, and the timestamp as datetime. Finally, when this function runs, we're going to be returning that clean data to another new pandas data frame. So if we just give this a run, so I'm going to just basically pass in the data frame from above to this function that we're going to be just running here and returning the head method again to see our data. Great, so now as you can see here, we have a pandas data frame with our 5 columns that we're now ready to write to S3. All right, so our next step here is we're going to be writing our pandas data frame to S3. So what this function is going to do that I've written is we're going to be passing in this pandas data frame that we've outputted above into this function, and it's going to write it to a JSON file in S3. And it will actually write multiple JSON files if we have partitions in our data set. So our first variable in our function is going to define the location in S3 that we're going to be writing our JSON files to. And now the next line is simply going to check if our data frame is empty. And then if it's not empty, we're now going to write our file to S3. So we're going to be using the AWS Data Wrangler toJSON method here. And this will take care of writing our pandas data frame to S3 for us. So the first parameter is that pandas data frame from above here and the path that we're going to be writing to. Next is going to be the orient. I've made this equal to record. So we're going to get our JSON formatted in a record format, which means we're going to have each array will have a row of data. And if an index exists in our data set, we're going to be passing that as well. So the sanitize column parameter will make sure when we're writing our data to S3, in the event we have special characters, it's going to remove them before writing to make sure that if we later wanted to create a glue catalog table over this, that we're not going to have any issues. And now this parameter is dataset is equal to true. This will allow us to actually write to specific partitions in our S3 directory. So now that I've made my dataset true, I'm going to pass in the partition columns. So what this is going to do is for every single approved date, we're going to get a different JSON file. So when this writes, I should have 2 different files being outputted, one for my 2 order IDs 4 and 5, and the other for 1, 2, and 3. And this is going to be helpful if you have, millions of records and you want to be able to limit how much data you're reading down the line back into pandas data frame or into other jobs. Great. And now mode, I've made this equal to overwrite. So this is going to overwrite any data that's there. Ideally, you probably want this to be set to append if you don't want to overwrite the existing partitions that exist. Then lines goes hand in hand with the orient parameter. So this will allow us to have a JSON object on each row in our JSON file. And here's just my logging message I'm passing if this is successful. So we're going to see successfully written, then how many records to S3. And what this is going to return is the name of the files that were written to S3 here. And then finally, if we had no records in our pandas data frame, we're just going to say no records have been returned. So it's not actually going to go through and perform this method on our data frame. All right, let's just give this a write. So now I'm just going to be calling this function here with our data frame from above. And now we're going to then print out our output. So Give that a run. And now we've successfully written our records to S3. We can see the path of the file that we've written to. And also here we can see the partitions which are highlighted in this list over here. So let's quickly take a look and see how our data looks in S3 that we've just written. All right, so I'm in my S3 folder that I've just written to. This is the root directory. And as we see, we've got two new folders that were written in S3, one for one date and the other for the second date. And what you'll notice is the column name is actually written into the path. So why does it do this? Well, by writing the column names into our folder name, we can actually query this down the road in AWS Athena, and it will recognize that this is part of the partition key in order to retrieve the values in these specific dates here. We just click on one of our files here, just quickly open it up to see what it looks like. As you can see here, we have 3 records that have successfully written. Great. All right, now let's walk through how to actually get this data to be written so that we can query it in AWS Athena. So if you don't care about querying your data down the road in AWS Athena, you can skip this part. But if this might be of interest, let's just walk through what we're going to have to do. So I'm just going to paste my code in. It's going to be similar from the method above, so it's going to be called the same. But what has changed here is that now we're going to be passing in a couple new parameters. We're going to be passing in the table name in AWS Glue that we want to write to, the database that it's going to be saved in, and the column names that we want to write as well. The column names is optional, but if you want to be very strict and define what columns you're going to be passing, then this parameter is going to be helpful to limit what you're writing to S3. Great, that's it. That's all we have to change. And now the only other line that I've added here is this method to repair our glue table because we're writing with partitions. So if we do not include this and we try to query it in Athena, we're not going to get an error, but no data is going to be returned. So by adding the repair table method from AWS Data Wrangler after we write our data, it's going to make sure that we're able to retrieve the data in the newly added partitions. So let's just give this a run here. And I'm just going to overwrite the other data that I've just written before by using the overwrite mode. So this is just currently running. And now you see we've successfully written to S3 again with 5 records, and we've got the paths being returned as well, which is great. So the data is going to look exactly the same, but if we head over to Athena now, and if we refresh our table in AWS Athena, we're going to see the new table we wrote to appear along with the columns that came from CloudWatch logs. Now, for some reason, as of Data Wrangler 2.14, when writing to JSON files with AWS Data Wrangler, it is adding this index_level_0 to the glued table, even though I don't have an index in my JSON file. If we run this query here, we're now going to get all our 5 records being returned. Now we're ready to perform SQL queries on our log data. So as you see here, I've written this as a Jupyter notebook, but this is going to be very easy to just turn into a Lambda function if we wanted to, and put this on a schedule and let's say run every day to find all the new logs that are coming in and be able to automate our logging process for further analytics. So I hope you found this walkthrough helpful on how to query, transform, and write CloudWatch logs to S3 and make it available to query in AWS Athena. Thanks so much for watching, and if you learned something or thought this video was useful, please hit that like button. If you're new to my channel, please consider subscribing so you don't miss out on my next video on working with data on AWS. See you next time.